Hello, good morning,
Hello.
everyone. I would like to introduce myself. So I'm Viktor Tihanyi from ZalaZONE Proving Ground Research and Innovation. I'm a team leader there, and at the same time, I'm also an assistant professor at the Technical University of Budapest. So I will present you the research and innovation activities inside ZalaZONE. Can you see my screen? That's perfect. So let's start with the topics. I would like to provide you a small overview about what are our major points that we are focusing on. So first of all, cutting edge research is the most important from our side, of course. Then we are focusing also on the education, I would say future proof. I will talk a little about later on. Dissemination of results is also very important part, and finally the knowledge transfer. Let's check inside ZalaZONE where we are located currently. So as you can see on the bottom left side of the overall proving ground, we have now currently a built up research and technology center, which is continuously improving. So we will have new buildings, but Dr. Hari will speak about this, I'm absolutely sure. Therefore, I skip this topic now, but we have currently 3 universities who are hiring offices and workshops nearby ZalaZONE, and 1 research institute. And I'm really proud that I can tell you that we, from the research and universities part, we have a small proving ground at the area. If you see my pointer, then it is here located at the bottom side of the big proving ground, which can be used for dedicated research activities. We have also dual education programs with the universities where they can send their students to spend time at ZalaZONE research. We have also at this place currently also industrial laboratories and the capability for startup incubation. Regarding the education that is dedicated to the ZalaZONE activities, 2 years ago, we have initiated a new master program at the Technical University of Budapest called Autonomous Vehicle Control Engineer, that is in English language, and we are expecting students from worldwide here. And this is a very special master program because it focuses really on the automated vehicle related topics, and we cover practically all those topics that are relevant here for CCAM related science. We have also another one that is computer science for autonomous systems. It's in another university in Budapest, and we have started as well a new program. It's a so-called B-Prof program, which is a little bit less than a bachelor that is focusing on vehicle testing. So those students who choose this education form will be able to support the testing of vehicles on a proving ground, for example. A little overview about our current partners whom we are collaborating with. You can see here that we have a lot of partners, also academic partners worldwide, as well as automotive suppliers and commercial companies. Just to mention someone here, we are collaborating with Bosch, Knorr-Bremse, AVL, of course. From the perspective of the academic partners, we have a very strong collaboration with TU Graz Virtual Vehicle. We are also collaborating with not only automotive commercial partners, but as well as from the mobile suppliers like Hungarian Telecom, and also from the perspective of the 5G device suppliers like Ericsson. We have also very strong relation with Hungarian public roads and also Budapest public roads. As Robert mentioned formerly, we are also planning to extend the activities not only on the proving ground, but to support testing and later on automated vehicle operation from the public road perspective also. About the dissemination activities, we are typically hosting 3 international conferences annually that are dedicated conferences. There, last year we had 24 Hungarian conference and workshop attendants. We were participating more than 30 international events like fairs and other kind of not scientific conferences. And we have a lot of scientific publications annually where the number is continuously increasing. Of course, due to the coronavirus situation, this year is a breakdown in this, but we expect significant increase in the near future inside these activities as well. As a next topic, I would like to talk you about our current research projects and the exact topics what we are focusing on. We have multiple ongoing projects. Currently, the list you can see here is not complete because we have also new ones in the list as well. But just to mention, you can see that we have a significant amount of budget for research-related activities. For example, we have dedicated research project for the automated vehicle systems research dedicated to the autonomous proving ground at Zalaegerszeg, involving 3 universities from Hungary. We have a higher education excellence program where we are focusing on AI-related research. We have also initiated collaborative research programs with Austria first, where we would like to extend to other countries as well. We are currently in discussion with German partners as well as with the Slovenian partners to initiate similar bilateral research projects. And we have also commercial partners whom we have collaborative research project, like for example Bosch, what you can see here. Some words about our fundamental research activities in the connected and automated mobility topic, what we are focusing on. So we are practically covering all areas on the fundamental research side. First, I can say environment perception is a really strong activity at our side, where we are focusing on from the raw sensor signal processing up to the AI-based fusion or AI-based perception methodologies. We are also very active in the testing methodologies of perception systems. And I also include here into the perception part the HD mapping related topics. For example, as Robert mentioned last time, we were also generated the HD map vectorized and point cloud data of the ZalaZONE, which will be available soon for all our partners who are coming for testing. This is a centimeter accurate level HD map of the areas. On the next part, we are dealing with decision and control part of the automated vehicle related topics. We have AI-based decision methodologies in research, static dynamic, trajectory planning and following, and we have control on the execution level as well as research topic. And we have also a special part, which is a new part, I would say. This is vehicle in control in case of instability. I will talk a little bit more later on this field also. Communication technology is also a very important part for us. As you may know, there are two evolving technologies currently available. One of them is DSRC, the other one is 5G. Actually, we don't know which one will be the winner. Therefore, we are focusing on both, also on the lower layers of the communication as well as on the application layer. And of course, on cybersecurity, which is a currently very important topic due to the impact on the future automated mobility. This is not only in the research activities currently. If you take a look in the world, for some years, most of the big automotive companies are started to deal with cybersecurity related topics. Many of them are acquiring existing cybersecurity companies, for example. And last but not least, in the fundamental research part, simulation technology, where we have currently our own tools developed, as well as we are using most of the available commercial softwares in our research team, where we can do standard software-based simulations, as well as we are able to customize the softwares. And for example, we are making a lot of kind of co-simulation where we combine the different software tools advantages as well as with our own tools in order to have a tool set that is capable for the highest level of abilities, state of the art and beyond. Regarding our applied research activities, at the moment we have two automated vehicles that are available at ZalaZONE. We had developed a Smart for 2 vehicle that is completely by-wire vehicle that can be controlled from any kind of software or CAN interface or Ethernet interface, whatever. We have also developed existing functionalities in it in order to demonstrate. So we have wallet parking ability fully autonomously for this vehicle. We have also a traffic jam pilot where we can realize camera and radar and LiDAR based lane keeping vehicle, so low speed ACC control as well as fully automated lane change with this vehicle. And we have also implemented a special platooning function on a DSRC communication basis. This vehicle we can offer also for our research partners, and we can do collaborative testing or research activities where they have the ability to get a completely automated vehicle to do the research if someone does not have the opportunity for that. The other vehicle for research purposes, that is a by-wire vehicle on the steering and the throttle level currently is a BMW M2, where we are using a steering robot and some manipulation with the throttle control. And with this vehicle, now we are realizing automated drifting. I will show you also a small video around. This is a very interesting research activity because in the future we think that for safety we will step into a next phase where the automated vehicles will be not only able to control the vehicle in the stability situation, but it will be able to control as well the vehicle beyond stability in edge cases. From the environment perception point of view, we have also a fully equipped Honda vehicle that you can see on the right side that is equipped with all of the state-of-the-art sensors you can see. So cameras, we have 7 cameras on the vehicle, 3 lidars, multiple radars, differential GNSS, and also thermal and night vision cameras, where we are able to collect data in a synchronized way, and also we are able to do real-time operation of the perception system during the vehicle operation. We are not only focusing from the perception point of view, the vehicle side, but we are focusing currently as well on the infrastructure side. I will talk a little bit later on. Another very important thing is that from the research point of view, we are doing special testing methodology researches. One of them is the so-called vehicle-in-the-loop methodology, where we can combine our simulation technologies with our real vehicle testing, where we practically bypass the perception system by a virtual world during the vehicle testing, and from the virtual world that is running in real time in parallel, we are able to inject back to the vehicle object level or currently even raw sensor data level information into the automated vehicle system. We have an even more complex testing methodology that we are calling scenario in the loop methodology, where we are doing the same. So with the real vehicle testing in parallel, we are running a simulation in real time, where we are capable also for the vehicle in the loop object level or sensor level information injection back to the vehicle. But from the simulation server, we are also able to control real proving ground elements. For example, dummies, pedestrian dummies, or even moving platforms or target vehicles. The current status that we have done a POC and we have ongoing application with Bosch on this system currently. And last but not least, a new topic what we are focusing on is that we are doing a research on complex cloud-based central system, where our target is to build up a real copy, so-called dynamic map of the environment in real time of the road users, where we will have the real-time object information in the cloud that can be used for providing information back to the vehicle, can be used for automated vehicle testing, and also, for example, the data for accident reconstruction and the support of the previously mentioned scenario in the loop system. In this project, our partners are Knorr-Bremse, Hungarian Public Roads, Ericsson Telecom, and some Austrian partners as well. Okay, and finally, just some highlights that out of the theory, what I mentioned. You can see some videos, what we are doing. So on that one, you can see our automated vehicle that is doing a wallet parking application here. And we are doing a parallel real-time simulation at the same time. You will see the simulated environment soon. And you can see that the vehicle in the simulation is acting in the same way as in the real world. And now a pedestrian, a virtual pedestrian comes in and the vehicle started to brake. In the next scenario, you can see that from the simulation server, we will control our real test dummy in the proving ground with a time to collision calculation to come in front of the real vehicle. This was our next scenario. Here, my colleague will drive the vehicle to the next scenario. But I can also tell you that in this video where we recorded, this was done not with an internal computer inside the vehicle, but the computer was an external server that ran the simulation, and the communication was a real-time 5G communication that was implemented in the ZalaZONE Proving Ground last year. So it was done in 2019, May, where the Proving Ground opening scenario take place. So here you can see the next scenario is a traffic jam pilot, where our vehicle reacts on the simulated front vehicle in the same way as it would have been existing there. And then the final scenario is coming, and my colleague will change the direction, and we will do the same with the real vehicle. So you can see that the Skoda vehicle will come in front of our smart, and it will do the same traffic jam pilot with an automated lane change at the end of the scenario. During the event, we were applying a very huge LED wall, you can see on the right side, and the audience was able to see the parallelly running simulation in real time from the demo location. Okay, so then the final scenario is starting. You can see that the vehicle will do the same traffic jam pilot functionality, and my colleague will push the turning indicator and it will react with a complete automated lane change operation finally. So actually, this was the final scenario here, and then practically this demo ended. And just a very short final video to you. So this is a recording of our BMW M2 vehicle that with it we are doing a so-called automated drifting. You can see that the controller of the vehicle is continuously keep the BMW in a stable drift state. Our next target is to realize not only the stable drifting, but as well as to implement a predefined trajectory with the vehicle. So thank you very much for your kind attention. And if you have any questions, then please ask.